here's another example of optimization topic, and this tells like the diagram shows a prism with a base of x times x length and length of 9 minus 2 times x. So here's the diagram, and the question is, what is the maximum volume of the prism? So well, pretty much, if this is a base, the base of this prism would be a square, and the length would be 9 minus 2 times x. So if we would like to calculate the formula for the volume of this expression, would be the volume of x would be equal to, well, the area of the base, which is, well, x times x. I'm going to write it fully, then I simplify it. X times 9 minus 2 times x. Now, simplify this. Simplify this would be, well, this would be x squared times 9. We'll make 9 times x squared. That x squared times negative 2 times x would be minus 2 times x to the third. So this would be the formula that will produce a volume. Now, if we are requested to find the maximum volume for the prism, then of course this is a problem of optimization. In order to do it, we have to pretty much follow up the steps that we did to find the critical points on any given polynomial. So we got to start by taking the derivative. Derivative, it will be 9 times x, 18 times x, I'm sorry. It will be 18 times x, and that will be minus 6 times x squared. Now, I'm going to factorize these guys. I'm going to factorize. First I got to equalize this one to 0 because we're looking for the critical points. And then we will have to factorize it. So I'm going to do it in 2 steps just to show you the step by step. And here we got this 6 times x squared. Now if we equalize this to 0, and we find the values that we produce a 0 at the end, substituting for this expression, I'm going to take as a common factor the 6 times x, and we get here 3 minus x. So basically we got here 2 critical points. The first one will be, of course, 6 times x equal to 0, and then here we produce, of course, 6 equal to x equal to 0. Now for the next one, this will produce a 3 minus x equal to 0. So and of course will be 3 equal to 0 in this one. So in a sense, we got here 2 critical points. We got this guy, we got this guy, the critical points. So one of them is going to be a maximum. Now, clearly cannot be, maybe could be the x equal to 0, but that wouldn't make sense from a realistic point of view. We cannot just make a diagram prism with a length of 0. So that would pretty much disqualify this value. But I'm still going to do the testing just exactly as if we were not concerned with something real. So I'm still going to do the testing for the sake of order. So sometimes could be helpful just to follow up this. Actually, I strongly advise you to always write all the critical values, even if some of them are not real. Just the only thing you can save is you do the testing only for the realistic values that you may find. So I'm going to pick a value. I'm not going to test here on the left. I'm just going to focus on here on the values that we got between 0 and x equal to 3. I'm going to evaluate with f prime of 1. F prime of 1, b prime of 1, I'm sorry. Should be volume. B prime of 1, that will make, of course, we got the substituting here, the 1. That will make an 18 times 1, which I'm just going to write an 18, minus 6 times 1 squared. So I'm just going to write the 6. So 18 minus 6, that will make a 12. Now, of course, this is telling us that this is a positive value, that the function in here, it ascends. It ascends. Now we repeat the testing with the values after the x equal to 3. So I'm going to pick b prime, let's say, of 4. So this would be 18 times 4 minus 6 times x squared. Now let's see. This would be equal to minus equal to minus 24, negative 24. So this is a negative value, so it's telling us that after the tree, the function will just start descending. So it descends. It descends the function. So pretty much. So in this case, for the x equal to 3, we got a value that's ascending, like ascending, and then descending. So this is clearly going to be a maxima. Now, if we want to find the maximum volume for this prism, well, we got to evaluate on this. We got to evaluate, to find, to write it here, to find the maximum volume, evaluate f of x. So let's pick f of x and we're going to evaluate, this case would be v of x, of course. V of x, so v would be v with a value of 3. Substitute v with 3. Let's see, we get 9 times 3 squared times minus 2 times 3 to the third. I'm evaluating here on v of x to find the actual maximum possible volume. So this would be at the end, of course. This is a 9 times 9 squared. 3 squared would be 9. 2 times the 3 squared, that will make it 27. So this would produce 81 minus 54. 81 minus 54. So we got at the end that b of 3, that would make 27. We got no units, so I'm going just to write the units to the third, just to make a symbol that this is a cubic units. So, and that would be actually that would be the proper answer, because this is the maximum volume. That would be it for this example.